Still living on git commit and git push? Time to level up. These 10 git commands will help you make smaller commits, move faster, and recover safely when things go sideways. Git switch is for switching the branches. As simple as possible. It is a safer alternative to git checkout, which is actually overloaded with switching branches, file restoration, and commit checking. So use git switch for branch navigation without the risk of accidental data loss. Git restore helps you undo the file changes without moving your branch pointer. Suppose you edited the user service class but later decided it was a bad idea. With git restore, you can replace the user service class with the version from the previous commit. Your local changes to that file will be gone. You can use git restore to make the user service class look like it did one commit ago, or you can restore it from a specific commit. Another example. Say you staged user service for commit, but then you changed your mind. You don't want it staged for commit yet. You can run git restore staged. In this case, the user service class will be removed from the staging area, but the local changes will be kept. So the file is still changed in your local folder, just not ready for commit yet. Okay, we know git stash. Git stash saves your local changes and returns your working directory to a clean state. This way it will match the head. But in some cases, git stash -p might be more useful. It lets you stash only the selected chunks. When you run this command, Git will show you each change and ask whether it needs to be stashed. You can use it, for example, when half of your work belongs to the current task and another half to the bug you accidentally fixed. This way you can stash only the unrelated changes and keep the useful ones. Another familiar command is git add. Git add adds file contents to the staging area. Simple. But what if you did a lot of changes to one file and they are not necessarily related to one task? With git add -p, you can add only the related changes instead of the whole file. When you run this command, Git shows the chunk and you say whether it should be staged, skipped, or split. Suppose your file contains 2 to-dos, one small formatting change, and a bug fix that deserves its own commit. So with this command, you can make smaller commits and have clearer history. Next up, git reflog. Suppose you lost a commit with important work or deleted a branch. No worries, this is still fixable thanks to git reflog. You see, Git keeps a local history of where you had and branches used to point. That memory is called reference log or ref log. So git log displays the permanent commit history of a branch. Reflog tracks all local reference updates, even if they were subsequently rewritten or deleted. So you lost your commits due to rebase or reset, or you deleted a branch. You can run git reflog, track the changes you deleted, and recover them. Keep in mind, though, that reflog is local. It means that it exists only on your machine. So you can only recover the commits you lost locally. Git bisect is a very interesting command that can help you discover a commit that introduced a bug. The command uses a binary search for that. You give it a bad commit that you know that contains a bug and the good older commit without the bug. After that, git bisect picks the commit between them and asks you whether this commit is bad or good. You compile the checked out version, test it, and see whether the bug exists there. Then you say bad or good. Git bisect continues narrowing down the range until it finds the commit that introduced a bug. After that, you can run git bisect reset, and that will return your tree to the commit that was checked out before git bisect start. Worktree lets one Git repository have multiple working directories. A repository can support multiple working trees, and that lets you check out more than one branch at a time. It may be useful when, for example, you are deep in a feature branch and then something happens in production. Instead of stashing, switching, and rebuilding, you can create a separate work tree and create a fix there. Git cherry pick takes one specific commit from elsewhere and copies its changes onto your current branch. Imagine a situation. You are on a branch feature UI, but you suddenly fix a bug that belongs to the main branch. You can switch to main and copy the commit with the bug fix without merging the whole branch. It may also be useful if you want one fix from another branch. So you can copy one specific change, not the whole branch. Note that cherry pick does not move the original commit. It copies the changes into a new commit on your branch. It means that the original commit will not be removed from the original branch. Also, cherry picking requires your working tree to be clean. It means no modifications from the head commit. Git sparse-checkout lets you check out only part of the repository. Usually, when you clone a repo, you get everything: services, docs, scripts, infrastructure, etc. But maybe you want to work only on one service. With Git sparse-checkout, you can do that. Note that the Git docs mark Git sparse-checkout behavior as experimental, so use it with caution. We know git push force. Git push force can accidentally overwrite other people's work, but there is a bit safer version of that, and that is git push force-with-lease. It enables you to force push your changes, but only if nobody pushed their changes since you last checked. How exactly does it happen? Git checks whether the remote branch still points to the commit your local Git last saw. If nobody else pushed, then Git allows the push. If somebody else pushed, then Git rejects your push. For example, you fetched from remote. There are 3 commits A, B, and C. You did your work and then you cleaned your commits with a Git rebase. And now your local history changed. Now you have A, B, X. Now you need to update the remote branch. After running git push force-with-lease, Git checks: is the original branch still at C, the last commit I knew about? If yes, it pushes, and now the original branch has ABX. But imagine somebody else pushed, and now the original has ABCD. Now, Git will say no to your git push force-with-lease. This is because the remote branch no longer points to C, it points to D. Okay, but this is still force push, so use it with caution, right? You can use it mostly on your feature branches. Avoid using it on shared important branches unless your team specifically works that way. And remember that there's no 100% safe force push. It's just less reckless push. So you should still pay attention to everything. And these were 10 useful Git commands that will help you level up your Git skills. Don't forget to like this video, subscribe to our channel, and until next time.